Good morning. Yeah, good morning. Okay, first speaker for today, Andrija. Says Andrew, but it's actually
Yes.
Andrija. So go ahead.
Yeah, hi everyone. So people call me Andrew because I realized early on that, for English-speaking people to pronounce Andrija, it was just too much work. So I'm now usually known as Andrew. Anyway, hi Belgrade. I'm so happy and amazed, and it's quite surreal that I have the opportunity to talk back in my hometown after not living here for so many years. And I'm not going to cry now, I promise. I'll cry afterwards because I have to deliver the presentation. So I'll be talking about think twice before dropping acid and throw your cap away. So it's all going to be about databases and acid and the cap theorem, as you might presume. So for any of the non-native speakers, maybe just quickly Google what dropping acid actually means. It's just a bit of a pun, but it's you'll find a lot of literature nowadays which talks about NoSQL databases, and I'm sort of urging everyone to take it with a lot of with a pinch of salt. So I'll be talking about acid. I'll be talking about the CAP theorem, and actually the last set of slides is the actionable advice is something that it's actually, if you want to take away something, is take away those last few slides, because this is what I reckon that's what people need to understand, what questions they need to ask themselves, and they need to know the problem space before they actually make good decisions. And a lot of the time people get burned because they don't know what they don't know. Has anyone been to Vlad Mihalcha's talk? 1, 2, 3, great. So Vlad Mihalcha, it was actually, I attended the talk, and Vlad is great at what he's doing, but second question, did anyone understand 90% or 50% of what he was talking about? Did you actually know all of this stuff before you came? So yeah. So the way Vlad presented is great. I'm not going to do that, right? And I was actually quite happy that Vlad did a lot of this stuff, because I'm hoping that everyone who's been to the session understands how complicated this is, and there's no way that people can actually digest all the different scenarios in a 1-hour talk. And Vlad was very fast. He was just going bang, bang, bang. He was just powering through. And unless you actually know the stuff pretty much inside out, you won't be able to keep up with it. So the whole point is, I'm not going to be talking about that level of detail. I'll mention some of the stuff, but I'll try to focus on, I'll try to make most out of the 40 minutes that I have. So just a little bit of background about the cost of dirty data, or we can rephrase it as the cost of data management or data quality management. So you must have heard a lot about direct impacts of bad data, right? You have legal consequences, loss of revenue, wrong decisions, What's actually less well acknowledged is the fact that there are indirect losses, which are what happens if your boss comes along. If your boss comes along and says, hey, how much is we know there's some dirty data, how big is the damage? And in most situations, you as developer have actually no idea how bad is the damage. You think, yeah, probably not big. So probably not big, what is that? What does it mean? So people who actually, there are some big companies that do serious level of data quality management, and they have to invest a lot of money into figuring out when the data goes bad, how bad it is. And there's another factor, which is loss of confidence in data. So if you've been on any data warehousing kind of projects where let's build another data warehouse, now it's all about data lakes, but it's a very similar thing in the end. A lot of these data warehouses, data lakes, if people lose the faith in the accuracy of the data, that project is doomed. And what happens is then people usually they don't even try to fix the issues after a while. They just go, okay, this data warehouse is bad. We're going to rewrite it, throw it into the bin, and start from scratch. And then another 5 years later on, the new data warehouse, if you don't do stuff properly, it will have the same fate. So data, if it doesn't have the confidence of the people, data is actually pretty useless. This is a very quick recap. I'm not going to do Vlad. This is a very quick recap of what ACID is. ACID is atomicity, so you think your commits. Consistency is integrity, so you have primary key unique key constraints, foreign key constraints. Isolation is concurrency control. This is where it gets really complicated. And your ability to think of the opposite of MongoDB 2010, where it was doing some silly stuff. I'm just making a little bit of a stab at MongoDB. And the CAP theorem is all about consistency, availability, partitioning, so it's and partition tolerance. So it goes basically pick any two of these. And there's nothing wrong with the theorem, but there are a lot of nuances which the theory doesn't quite talk about, and there are stuff that people interpret it sometimes in wrong ways. Now, why is this actually really important? The theorem was really important because it was in the early noughties, it was Amazon and Google were leading the pack. They were saying people have to have internet scale, whatever that means, web scale. So the old databases, they just couldn't keep up with the loads. Old monolith database couldn't keep up with the loads necessary for high volume e-commerce activities. And there were a lot of horror stories I read years ago, I couldn't dig out the horror stories at Amazon of their old Oracle databases when they used to chuck everything into it and all kind of issues they had because they were the biggest Oracle database and a lot of Oracle people were scratching heads when faced with such problems. So out of all of this, there was a coin term which was basically available soft state eventual consistency, meaning that yes, there will be occasional inconsistencies, and this is good enough because it gives you the scale. And that's how it's actually applied in practice. Now, just a very quick rundown of what consistency models NSSI SQL talks about. Just a very brief thing. I'm not going to go into the details again. I really ask you to actually look at Vlad's blog and other people's blog and look and see in detail what it means. And there are some inaccuracies in the NSI, or there are some lack of detail if you really want to get down into that. Now, the actual consistency models, this is like a snapshot as of a couple of years ago. There's a lot of research that went into it that's going on into now, and it started all about 4 or 5 years ago. So there are a lot more consistency models out there than it's what actually NSI SQL talks about. And there is sort of three, I'll talk a little bit later on about the 3 areas. So you have the top ones are the ones which are most strict. And then you have the ones on the left which are kind of like sticky session models which assume, I'm not going to talk about it too much because it does get complicated. And then you have the green ones which are less, basically they are less stringent. And if you see here, for example, I'm going to ask you some quick questions now. So what is do people actually have an idea now, their default consistency models that they use on the most recent project? And most of the time, I get people don't actually realize, it's one of those, say, Oracle or Postgres or MySQL or SQL or whatever, MongoDB, whatever gives you, but people don't realize what is the actual consistency model that their current data store database uses. Secondly, they don't actually ask themselves what does it need to be, because they have to think quite hard about some of the intricacies. So, and this is where it gets quite diverse depending on the use case. So if you have something like log mining, tracking logs, tracking clicks, if you have some inconsistencies, it's the question, it's pretty much who cares. People are not going to stress about losing a few clicks or likes or when you have inconsistencies there. If you have, on the other side of the spectrum are going to be your trading systems, high volume trading systems, where if you screw up some orders, some trading orders, then you could be in deep trouble. And the actual timing of the models and the bids, so it's especially complicated when you have bids and orders. And this is why, in fact, a lot of algorithmic advertising is based on this, and Google is actually very much in this space. Third question, what can you expect out of a typical microservice architecture? So if you have lots of services together, you use, say, REST, and this is really a question for you. What can you actually expect? What does it give you? It gives you nothing. I mean, it gives you no ACID, not even no atomicity, it doesn't give you any durability as well. You have to do manual retries. So Microservices, they are pretty much the way forward for a lot of the people, but I am a little bit, before you step into them, you have to be quite mature enough and you need to know what you're getting into, because a lot of these issues can bite you if you're not aware, and you have to put in a lot more effort. You don't get anything out of the box for managing distributed transactions in the REST world. And finally, so I'm going to go back to the old diagram, and what's another huge additional cost to managing dirty data or trying to prevent dirty data? It's the cognitive load on developers to understand and manage all the complexity, and that should ideally be managed by the DBMS. So what does this mean? It means if you're a developer, you have to now, hopefully after this talk and after you read a little bit more, you realize, okay, maybe I need to read a bit more. And maybe you realize that, hey, I'm actually, in my world, I need to take care of all of this stuff. And now you have all these additional things you need to learn, you need to keep on your head, you need to manage on your own, because there are not necessarily good enough tools for you to do that. So now there's all this additional cost, and it will slow you down or it will cause other kind of pain. And this is exactly why I'm just quoting word for word from one of the Google research papers. You can read this through, but it basically says yes, pretty much exactly that. So Google, because they have to take care of all of this stuff in the background, they're a huge company that can throw in lots of engineers. They still reckon, well, it's not really a developer's job who's developing applications. It shouldn't be his or her job to manage all of this complexity. It should be easier. And Google are web scale as well, so they always have scalability requirements. Now, F1 became Google Spanner, and you'll see one of the, I'm actually really interested to attend one of the upcoming lectures about Spanner, but there's a few more databases around which are managing scalability and consistency in their own different ways. And the reason why they can manage that, there are some special reasons why they can actually do that. So, a little bit of a joke to say, there was a time where SQL was ruling the world. NoSQL was starting to be prominent with a lot of developers. And then we came from NoSQL, not only SQL, and now it's NoSQL. Things are kind of turning around, and a lot of it is because people realize that just jumping onto a new technology without understanding all the pitfalls, this is not necessarily a good idea. And in the developer space, a lot of things, we try to think of ourselves, the developers, as very calm, rational people who know their stuff, but there's a lot of hype, and I've been around enough to sort of recognize there's a lot of hype, there is a lot of trendy kind of fashionable things, or people jump onto the latest and shiniest things, and then you hear someone like, it was Mark from yesterday, who's been around for decades, and it really need to listen to the guys who've been around and who still know their stuff, who are still up to date, because you see a lot of old problems that were solved decades ago, and then people try to do new technologies. They don't realize that the old problems are still there, they're still valid, and you're just sort of trying to sidestep them, or don't even understand what the problems are. So, things have a way of going around. Let's talk a little bit about the CAP theorem. So it was all about, again, availability, consistency, partition tolerance, and you pick 2 out of 3 is the way it goes. Why I reckon it's kind of too simplistic for practical applications, not for theoretical, but for practical, is firstly because, so let's talk about availability. Is there such a thing as 100% availability? No, there isn't. There's always, you're talking about how many nines. There's another aspect which sort of is not covered by the theory, which is latency. So if latency is too high, then the system is de facto unavailable. So if you have to wait for 2 minutes until you get a response from a web page, the system is not available. Like to a normal user, that's not available. Consistency, what isolation, which exact isolation level they're talking about, it's actually linearizable. No one actually uses linearizable, or, I mean, there's a, linearizable is a kind of like a little bit of a strange model because it's, there are some implementation of the strong serializability, which is both serializability and linearizable, but not of linearizable itself. So it's a kind of like a theoretical model. It's not necessarily used in practice. And then you have some other, I just wanted to throw some other kind of quirky aspects is that, yes, the partition tolerance is not taking care of any sort of InfiniBand clusters, unique kind of funny hardware. It's very much specific to commodity hardware and not necessarily even shared storage. So is CAP completely off the mark? Well, no, it's not. But the one interesting thing, this is what I'd like to highlight, is that CAP, that if you're saying pick the consistency and partition tolerance, is that if you look at this particular model here, which is read committed, that actually doesn't fall under the pick 2 out of 3 zone. So you could call it effectively like a small lowercase c AP, not capital. So it's not a very strong consistency, but actually read committed is the default model of Oracle. So if you go to Oracle and you don't actually bump up the consistency model, that's what you get. You actually get read consistent. So it's not read consistent is not, it's again, it depends what exactly your scenario is, but it's actually way better than no consistency at all. So something to keep in mind. And this is one of the reasons why the new SQL engines can actually deliver what they claim, is they basically go for mainly for read consistent statement, and that's if you want to bump up the consistency even more, then basically they can't, then the availability actually goes down. And now I'll talk a little bit about let's say, what's the more meaningful way of defining the database problem. All right, so that's what everything before was just an intro. So now I want to give you some practical advice to go through all of the points and to understand that if you actually understand your application problem domain, if you know the solutions, if you go through this questionnaire, I reckon the risk of you getting burnt is a lot less than if you actually just go jump in straight away. So let's start. So ACID, do I need atomicity? Do you have to be able to commit things in a batch? How I'm going to handle data referential integrity. So yes, you can drop all your foreign keys. So how are you going to make sure that you don't have some funny bit of application logic that's not going to mess up your data? Are you going to put in some special test cases, or are you going to try to run some queries post hoc to try to figure out if there's any data inconsistencies? So if you have to do that, firstly, you have to think about all of this stuff. Secondly, you have to implement it. So thirdly, you have to go to your boss to say, yes, this is what I've done to make sure that if you drop your foreign keys, you need to do a hell of a lot of other steps to ensure that you are covering your all the holes. Which isolation level do I need? Do I need to compromise to put in? Do you need to put in some other measures to figure out if there's stuff going wrong? Do you need to backtrack, look at all the logs, look at what's happening, and figure out if there are some data inconsistencies post hoc? Are you okay with losing data? And if so, how much? So the funny story is that sometimes databases do lose. In some circumstances, no database is perfect. It might actually lose data. And maybe it's not actually a huge deal. Again, depends on the context of your application. If you're losing financial transactions, that's very bad. If you're losing likes or some log files or some whatever, some sort of instrumentation data, then it's probably okay. So you have to also be aware that during, if you take one of these products which have complicated sharding techniques or partition management, these products are very complicated, and they may not, like, this is very, it's still a very new area, it's still quite immature, and don't expect that whatever your vendors tell you that it's actually, that's 100% bulletproof. Availability latency, what are my availability and latency requirements? What are the trade-offs between availability, latency, and consistency? So it's all kind of, it can be quite challenging to try to think of the trade-offs, because sometimes you have really simple scenarios, but sometimes you think, do I need the 4 nines, 3 nines, 5 nines, how many nines do I need? What's the actual response time? Is it 100 milliseconds? Is it, when you start combining different microservices together, then quite often you think, okay, 100 milliseconds per service is okay, and then you start changing them, and then there's 20 services you need to call in sequence, and it's like suddenly it's, okay, it's 2 seconds or 3 seconds, and then I need to call another web service from a third party, and then it's, boom, it's 4 seconds. So yeah, if you are into this space, it can be, you have to, again, sort of plan ahead and try to get a feel of where the problem could be when you're going through, especially through microservices. At which point high latency translates into de facto unavailability. We covered that before. Performance scalability. So what are my 1 to 3 year performance requirements? Maximum theoretical performance requirements. So if you don't have, my point in this question is, if you don't have huge scalability requirements, then why are you trying to make your world very hard by sort of going into technologies which offer you a lot of scalability? As in most cases, there are always trade-offs. So if you're picking something else, if you're picking something that you don't need, maybe you're actually trading off unknowingly for something else that you do need. How well do I expect the system to scale with extra hardware? So for example, in 3 years, if I need to add some more hardware, do I know, can I actually try to verify to make sure that the software itself scales well with added hardware? Or in 3 years, there's going to be faster hardware, but a lot of the hardware nowadays tends to be around parallelization, so it's not, things are not generally getting faster on per core basis, you're just getting more and more cores. So with more parallelization, you have more concurrency challenges and parallelization related challenges. So don't expect that the hardware in 3 years will, that the improvements in hardware are going to be an easy way of scaling up. Performance workloads, right? So this is, in the database world, this is where you need to know your stuff. Because there's a lot of different, when the database works, there's a lot of different ways of database accessing the data through indexes and full table scans and partition scans and index reads, scatter, like random reads, large volume reads. Talking about column databases, I'm not going to cover all of this stuff here, but you kind of need to understand the type of workloads that you will need for the application that you need, because that will govern what sort of database engine or engines you select. For example, Oracle is a kind of like a quite okay at everything and not spectacular at anything in particular. So there are better, if your problem area is more narrow, there are actually better, there are databases that will fulfill some of the workloads very well. But then again, if you need something more flexible, then you'll need to scratch your head again. Will my database schema evolve, right? And you can sort of imagine this is, you're probably guessing this is about NoSQLs, because this is about NoSQLs. I will argue offline with anyone. I'm very happy to argue that there is no such thing as a schemaless database, but I'll sort of put that aside, and I can have a chat with you one-on-one why I really think this is not the case. So you always have a database schema. The question is it going to evolve? Because any sort of evolution of the schema, getting more complexity in the schema is going to be, you're going to have more and more pain if you're in the NoSQL world. It's not a, NoSQLs are sort of schemaless NoSQL. Let's call them schemaless NoSQL, as I'm talking Mongo and Couch. They're not great at sort of flexible access and evolving schemas. They just suck at it, basically. Do I have many different pathways of accessing data as joined? So if you have like a very specific, if you only have like a very few types of queries that you're accessing the data with, then you can live with, you can optimize those particular access points using a specific database technology, and you can do sort of manual optimization. But then if you have complicated schema and lots of different evolving access points, then if you don't use a database engine with a sophisticated query optimizer, you're going to spend a hell of a lot of time on virtually manually optimizing every single query. So what happens right now is that if you use any of the normal SQL databases, you issue a query, and it can be a big query, and there are a bunch of statistics about all the data and data distribution, and you have a sophisticated optimizer that runs thousands of different combinations and reckons, okay, now I will use this particular path, and it does a hell of a lot of work for you. If you just try to do everything from hand, you basically need to understand everything that the optimizer does, and you need to do it for every single query. And now I'm going to talk about boring stuff which developers don't care about. Well, developers in the old world, in the new DevOps world, everyone cares about data recovery and resilience. So what happens when something goes wrong and you need to do like database restoration points? So, okay, this is not too much to do with the consistency models, but you'll find that if you have some databases which are kind of very light on consistency, they usually don't have as much functionality in terms of restoring pointing time. Like most of the old school databases, that you can say restore as of this particular millisecond, and it will actually restore. You can discard. You can take an old backup and just roll forward all the changes as a one date. And if developers don't see this side of the real world, but bad stuff happens. You have maybe viruses or corrupted data or some really dodgy hardware failures that you didn't predict, and a whole bunch of other stuff. And you do need to do once in a blue moon. You actually need to do this kind of stuff. If you're stuck with a database engine that has a very limited possibility, you're going to be in trouble, or you won't be able to actually restore exactly what you need to restore. Standards. So this is all about. So my point is SQL is a standard. If you want to migrate to another database, especially now with Hibernate and the likes, it's very easy. It's pretty easy. I wouldn't say it's never painless. It's always migrating databases is never a straightforward task. There are always other things to take care of, not just the application side, but it's a hell of a lot easier than if you have to rewrite all the data access layer yourself. And a little bit of cost of ownership and risk. So what am I prepared to pay upfront for design developer versus ongoing? So a lot of the new databases, it's quite tempting to go with them because it's really easy to build stuff up front. You can just shove in your JSON objects in a data store, and off you go. In one day, you have something up and running. But if you're talking about long term, then you'll probably find that all of the stuff which was easy later initially, then there's a price to pay long term. Risk appetites. Are you okay to go with one platform and then say, okay, now after 6 months and going for this, we realize that it's not the right thing. We have to migrate to something else. Are you okay with that scenario? Are you okay? And if you go production, are you okay for late night phone calls when something goes really wrong? So this is the cost of unknown. Is whenever you're venturing into something unknown, not very well understood, there's a cost, there's a risk that you're going to get late night phone calls, which are not so fun. And there are a few other things also to consider, which is how much monitoring instrumentation do you need around different kinds of queries? Again, more mature products have got, just because they've been around for a while, and there was a lot of input from DBAs, all kind of real DBAs, into what sort of instrumentation is useful. So you have very mature products, and then some of the new products probably wouldn't have as much instrumentation capabilities, and especially if you're talking about more complex queries, especially also if you're talking about alerts. If you are sort of an ops person, if you have some degree of ops experience, you know that alerts and getting timely alerts is one of the key things of keeping your system up and ready. If you get no alerts when something goes wrong, you are screwed. If you get too many alerts, what happens is that people just ignore them, and then when the real alerts happen, you're still screwed. So getting that right balance of alerts is not actually easy. It takes a lot of trial and error, and mature products have a lot of this sort of common sense trial and error built into the defaults. Integration with existing APM tools, so you may use a lot of APM tools. There are some pretty good ones nowadays, but you don't want to have multiple like performance monitoring tools. You try to consolidate. So does your database, what sort of integration with your existing tools does it support? Security. The DBMS has at least basic security, so it's basic means just like usernames, passwords. Of course, that's all simple, but then also some basic checksums around data. And then the next level would be at the very least encryption, like transparent encryption to satisfy like PCI DSS requirements if you're in the credit card space. Also encryption, and then encryption security-wise, it can go even further. A lot of the old products, they integrated with the HSM, with hardware secure modules. Now, if you're in the banking space and other kind of space, then these are pretty actually useful things to have. If you're, again, it really depends on the level of security that you need to support. Multi-tenancy, this is one of these, in the new sort of serverless Docker world, there's a lot of useful things can come along when you actually when you have multi-tenanted infrastructure. So it can be quite helpful. It's not, you can probably work your way around it, or build some sort of build your own fake multi-tenancy or do stuff like that. But it's always, of course, it's always easier when you get it out of the box rather than having to develop it yourself. I also wanted to point out that basically these are all your, if you go through a lot of this, you'll just, you go to Wikipedia non-functional requirements, you'll see all of these kind of criteria. And yeah, this is just a good checklist of you to go through whenever you're sort of in that space, which database. I reckon this is a pretty exhaustive checklist to make sure you haven't left something important out. You can just link me. I'm happy to share this. This is not, I can publish, I'll publish as well as Creative Commons. I'll just share it with everyone. And then there's, I wanted to point out there's a few things when you say you got your nice and shiny, you really think, okay, there's some really cool products, I want to try them out, and then you start talking to the vendors. So these are my suggestions for the kind of questions. So so you go through them all. So you should compile all these questions, and you basically to understand your requirements, and then you put them all through the vendors and say, okay, please state how your product addresses all of these requirements. And then you ask them, well, show me the money, right? So, of course, I was actually for a couple of years I was in a sort of a pre-sales role as well. People tend to a little bit bend the truth sometimes when they need to make a sale. So how do you get some sort of a commitment from your vendors that, how do you get them to accept the pain if something does go wrong? Or it's basically to say, one of them is to actually tie them into some sort of KPIs, to tie them in some sort of commercially, to try to put some performance level, like performance objectives. It's actually quite hard to do it commercially. Typically the easier way is to actually demand for evidence. So I've quoted, for example, I quoted some of the slides I did is from a website called Jepsen. This company, there's only actually a few guys running it. They do a lot of exhaustive tests on consistency, asset level consistency. So they've actually developed open level suite of testing software, which they run it against So they ran it against Mongo, against Kafka, against a lot of different kind of distributed messaging systems and data stores, and they published all of the results. So if your vendor doesn't have any real evidence of how the system behaves under under a lot of stress and under a lot of load balancing stress, and also under a lot of repartitioning, resharding. These are the very kind of complex scenarios that can go wrong. And if you look at some of those tests that were performed, virtually every single vendor failed some of them, right? So it's actually unreasonable to expect that a new database, very complex product, is not going to have some failures. So the best that you can do is talk to your vendor and ask them to show you, to open up their hearts and show you exactly where they stand, so that you can make an informed decision. And then this is where actually also it gets quite complicated, right? So let's say, for example, okay, I've gone through my checklist and I've selected, I need a few different performance workloads, and I don't want to go Oracle because it costs just too much money, sorry. So I would maybe like to select Cassandra and Spark, and then I can maybe do a bit of mix and match, and then I can do Spark for certain kind of queries, and I'll use Cassandra for other kind of queries. So that's actually, there are some real possibilities there, is that you can use a couple of different open source technologies which are integrated or semi-integrated or integrated well enough to actually make the whole thing work. And lastly, how much support do I need for open source solutions, right? So it's open source solutions are great until you work in a huge company, and then you need to know, okay, when the proverbial crap hits the fan, who are you going to call? How soon can you call someone to actually help you out when minutes count? So databases are very, why a database is hard? Because you can't, like with the application servers, you can sometimes do reboots, you can do, let's just roll back and reinstall the old version of the application, which we know was working fine. With databases, it's always harder. You can't, a lot of the time, you can't just rewind the clock back, you would lose data. And you need, when in the operations time, when something goes wrong, you may need to have a very firm idea of who you're going to call, how quickly they can resolve issues, how good your support team can actually resolve issues. So it's, with a big company, if you approach a big company, then you can commercially arrange a deal which is going to say, if you don't actually perform well, I'm going to pay you no dollars, and you'll suffer badly. So with an open source community, unless there's someone there who's actually willing to put willing to risk some of their revenue, it's actually, you're probably not going to find, you are taking on the risk as well. And just to very quickly, getting towards the end, I'd like to mention a few, just sort of quickly grossing through some of the big new SQLs. I'm not endorsing any of them. You'll have to do your due diligence, do a lot of research before you start using them. But why am I mentioning them is because I think the era of some of the old databases is sort of getting to, it could still be another 10, 20 years, but I think they've sort of peaked. And I think a lot of the new technologies will take over, just because the old ones are not. The scalability part is still something that will be more and more of a requirement. There's probably going to be other new requirements, especially with microservices. I'm not actually exactly sure where things will be in 5 or 10 years, but there will be new requirements. I think the old players have it's one of those, maybe you could call it one of these aging software products, where they were doing really well. They were quite well to the problem areas as of 10, 15 years ago, not so well now. On top of that, you add sometimes ridiculous licensing fees, and it's not, I don't think they're sustainable. So I see a lot of new players as pretty interesting something you should definitely keep up with. And next steps, read more about consistency models, go to Vlad's blog and other people's blog. Start playing with new SQL. Share some of your pains and questions with me or with other people. It's always, you know, virtually everyone has some sort of a horror story into database, and whether it's NoSQL or something from the past, there's always interesting horror stories to share. I have a few as well. And bottom line is, so anyway, this is a quote from one of the websites, is like anyone who's trying to say consistency models is right or wrong, you know, they are either biased or they're trying to sell something, and you know, you have to think about the actual domain area, the application, the consequences of data going wrong, and then you can actually make an informed decision. And that's pretty much it. And I'm happy to take questions.
Yeah, we actually have a couple of questions.
Sure.
So, first one, how we should make all these decisions when the project is in its infancy? Not all requirements are known at that point. Go with the tech you know the best, or with something that you can easily change, design for change?
Very good question. So, when you're making if you have a lot of unknowns, that's a kind of this is why I'm saying flexibility is a good thing, right? So, if you look at the questionnaire, so what is the, let me find this slide here. What is my risk appetite, right? So it's like kind of like, you think if there are a lot of unknowns, that means there is some risk. If there is risk, and you kind of need to balance it out, you need to kind of weigh yourself to say, if there are some serious unknowns and they could really bite me up my behind, then I probably want to stick with the safe, right? So you kind of have to put it in those sort of terms. If there are some requirements and your traditional DBMS is not going to fulfill them, then you're kind of pushed into the risk zone anyway, and you have to take that risk, and you have to move along with it, and you have to try to validate. Then one of the key things that you need to do from a project management side is manage the risk, and as soon as they materialize, then you can try to switch and try to mitigate. Again, this is why SQL is quite good, because you can still change halfway through your projects. It's not that actually painful changing databases. It's much more painful when you go full production and sort of when you're quite mature in it.
Okay, another one. SQL or no SQL, by your experience, which one you choose at most cases?
I choose SQL because no SQL, I see there is definitely use for it. You can use it for storing temporary information, like everything from couple of days to couple of months, kind of like temporary information, meaning that this information is not going to be kept for long term. Or if it's something completely where you don't care too much about the data itself, you're talking about logs or some databases where you have very limited, when you know that the requirements are not going to evolve for next couple of years, then it's kind of okay to go NoSQL. As soon as you start getting into more kind of like, I don't know what requirements I'm going to have in a few months or in a couple of years, and I need to be flexible, then NoSQL, I reckon, becomes more of a liability than an asset.
And the last one, how do you at PayPal handle scalability in processing payments where consistency is super important? Do you rely on traditional SQL database?
Yes, we do. And I can't disclose too much publicly, but if you buy me a drink, I'll talk a little bit more about. I mean, we still use Oracle, but we also use Cassandra and Couch as well, and Mongo is sort of semi in use. But I can't talk too much about publicly what we do, why we do, without getting a whole bunch of approvals. So, but I can talk to you privately about it.
Okay. Anyone else? No. Thank you.
All right. Thanks. Thanks all.